Okay, hello, welcome, and welcome back. So I just want to talk to you briefly about scientific notation. So if we're talking about carbon, which could be as simple as a charcoal briquette or as rare as a diamond, carbon, if we have 1 gram of carbon atoms, we have 50 some odd number of atoms, a number so big it's hard to find the number billions, trillions, quadrillions of atoms that we're talking about. Or if we're talking about a single carbon atom, the radius of one single carbon atom is 0.00000, etc., 77 meters, very small. And so we use scientific notation to be able to show very large and very small numbers in a understandable way. To do that, there's 3 main parts to a number in scientific notation. There's the decimal part, a number that's usually between 1 and 10 and carries the significance of the value. The exponential part, which is a multiplication times 10 of that decimal part to some value. And that value can be positive or negative. If our original number is more or less than 1, and that will multiply in orders of 10. So if n is positive, well, 10 to the 0, I guess, is not positive nor negative, but 10 to the 0 is 1. So if we have a decimal part times 10 to the 0, it would really just be by itself. 10 to the 1 is 1 times 10, 10 just 1 times, so that would be 10. So it would be multiplying the decimal part by 10. If the exponent is 2, it would be multiplying 1 times 10 times 10, or it would be multiplying it by 100. 3 would be 1,000, etc., etc., and it would continue in that order, getting exponentially larger as the exponent part gets more positive. And then, of course, n can be negative, and so you would be taking 1 and dividing it by 10 n number of times. So again, 10 to the 0, negative 0 would be 1. Then 10 to the negative 1 is 1 over 10, so 0.1. So you'd be moving the decimal place then to the left 1 time. 10 to the negative 2 is like multiplying by 0.01 or dividing by 100. And 10 to the negative 3 is dividing by 1,000 or multiplying by 0.001. So just a couple examples to show you how I would do this. So if I had a number like 7,538, I would look for a decimal part between 1 and 10. And so that would be 7.538. And I would move the decimal point from its original place to get there 1, 2, 3 times in the positive direction. So this would be 7.538 times 10 to the 3. Let's try another one. So this is a number that's more than 1, more than 10. We're going to be multiplying this in the positive direction, 12,600,000. And so our number between 1 and 10 is going to be 1.260000. And there is no starting decimal point. We'll add 1 in, more on that in just a second. This isn't a number that necessarily has significant digits, but we'll put a number here and count. We're going to go in the positive direction 1, 2, 3, 4, 5, 6, 7 times. And so we're going to put 1.26. And because we don't know whether or not these zeros are significant or not, and more on that, if you're curious, in the significant figures videos, Because we don't know if they're significant, we're gonna drop them. So just making the number 1.26, the values we know are significant, times 10 to the 7. So 1.26 times 10 to the 7, which is just a much more wieldy way to write this value, but it means the same thing. Here's one that's less than 1, right? A number that's less than 1. And so we'll put our decimal point, 3.02 is a number between 1 and 10. So how do we get there? From where we start, we go 1, 2, 3, 4, 5 times. But this time in that where n is negative, because we'll be dividing by 10 5 times. And so this number will be 3.02 times 10 to the negative 5th. And if we're given scientific notation and we want to go to the decimal notation, so if we have 7.41 times 10 to the 5th, how do we have in decimal? So start with the number 7.41, and we're going to move the decimal point 5 times. We'll need a few zeros. So we'll start here and go 1, 2, 3, 4, 5 times 2, 3, 4, 5. And so we have 741,000 is 7.41 times 10 to the 5th. 1.41 times 10 to the negative 2. Same idea. We'll start with the value 1.41 between 1 and 10, our decimal part. We're going to have to add some zeros, but in this question, we're going with a negative n value. So we'll be moving the decimal point to the left in the less than 1 direction. So we'll need to add zeros on the other side. Let's see. So we're going to go from here, 1.41. 1, 2 times. So we'll have 0.0141 as our value. All right, so from there, I feel free to try the scientific notation exercise and follow up with the recording on the correct answers. All right, good luck.